All right, so I'm not going to go through this whole thing, but I just want you to take a look. Please make sure you look at example 3. Make note here, it says, at which points is the graph discontinuous? This answer would be x equals, wherever the graph is not continuous. And then when you talk about the intervals, you would start at -5 and write an interval notation from left to right. So the answers are posted on Blackboard. You can take a look at the answer key. What I want to take a look at here is you're given a piecewise function, and you're missing the k value. We're going to stop here. Okay? We're missing the k value, and what we want to do is determine what does k have to be so that, just like that one piecewise function where, what was it, -1, -2, where we filled in that hole, we want to know what is the value for k so that will happen. So what we need to make sure we test in the end is the definition of continuity, meaning I still have to test the limit from the left, the limit from the right, and f of, 1. So what I need to look at here first is, if this function is continuous, remember the first part of the definition is that the limit from the left has to equal the limit from the right. So what we need to do is evaluate the limit as x approaches 1 from the left, and that means we're going to use this quadratic, 6 minus x squared. So what does that give me? When you're evaluating a limit from the left and from the right, what are we allowed to do? Just plug in. Yeah, direct substitution. So what's the value?
5.
Yep, 5. Okay, then we want to evaluate the limit as x approaches 1 from the right, and that leaves us with x plus k. All right, this is the problem. This is my unknown. So this gives me 1 plus k. I just plugged in my x value. Now, if I know that this is continuous, the first part of the definition says that the limit from the left has to equal the limit from the right. The limit from the left has to equal the limit from the right. What does that help me with? Yeah, I can find k. So you have 5 is equal to 1 plus k, meaning if this is continuous or that the limits are equal to each other, the k value has to be 4. But I still need to test that f of 1 is 4. You need to show the work. Okay, that's your justification. It's not just, well, yeah, because I said so. So what you do is, I know we've done it already, but we're just going to write it down. We have the limit as x approaches 1 from the left, and I'll just write f of x, we said is 5, because we did it right here. The limit as x approaches 1 from the right. Now we're saying this is x plus 4. Agree? When I plug in 1, I get 5. Left and right equal to each other. They're approaching the same value. The last piece is evaluate f of 1. How do I evaluate f of 1? Yeah, you plug 1 into the function that has the equal to in the inequality. So you plug it in the top. So in this case, it's 5. This is your justification. You're done.